Hello PreCalc students, these are your 10-2 notes and we are still evaluating limits, but whereas in lesson 10-1, this is 10-2 today, in lesson 10-1 we worked with limits where we could find the limit just by substituting. Today we're going to have to do a little extra work to find the limits, and that's because today's limits will have holes. Okay, so the function will have a hole at the value we're trying to eliminate. Remember that you can still find the limit of a function if there's a hole, because it's possible to approach the value from the left and approach the value from the right and have it be the same value. So if you look down here, you see that you have two special functions. Now these you're just going to have to memorize because we don't have a method for evaluating these. But if you have the limit as x approaches 0 of sine x over x, you can see right away that you're going to run into some trouble, because if you evaluate the sine of 0, that's going to give you 0. And then if you plug 0 here, you have 0 in your denominator. And that seems like it must be undefined. But actually, when you have 0 over 0, often this is a problem that you can fix. The indeterminate form is when you get 0 over 0, and this is often a fixable problem. Okay, so let's look at sine x over x. I graphed it on the calculator for you. So you can see over here that if you have y equals sine x over x, you can see it's getting closer and closer to the y value of 1. And if you look at the table of values, you'll see that there's actually an error when the x is 0, and that's because of a hole. But it is approaching a y value of 1. So the limit as x approaches 0 of sine x over x is 1, and that's just one that you're going to need to memorize. Memorize these. Okay? And then similarly, there is another special limit. The limit as x approaches 0 of 1 minus cosine x over x. Again, if I substitute 0 in for x and for x, the cosine of 0 is 1. So I would get 1 minus 1 over 0, and that gives me 0 over 0. But again, this is the indeterminate form, which is a fixable problem. And in this case, let's see, go to my y equals, and I'm going to turn off that graph and turn on the other graph. In this one you can see it seems to be approaching 0. You can look at the table of values and you can see when x is 0 you actually have an error. That's because there's a hole, but you are approaching a y value of 0. So this answer is 0, and again you're just going to have to memorize that. Okay, so when you see a rational function like this, it's possible that you can substitute in. You should always try to substitute in before doing the hard work of factoring something like this 5th degree polynomial. To substitute the 2 in without a calculator, you might want to do synthetic substitution. Remember, which looks a lot like synthetic division. So to put 2 into the numerator, I would have 2, and I would have 8. There are no x to the 4th, so 0, negative 6, 3, negative 4, 1. And you're going to bring down the first one, multiply, add, multiply, add, multiply, add, multiply, add, multiply. So we have 2, 12, and add to get to 13. So remember that the remainder of what would have been polynomial division is actually what f of 2 is. So on top we get 213. Okay. On the bottom I could do synthetic substitution again, or this one's pretty quick, I can probably do it without. So I would do 3 times 2 to the 4th minus 2 times 2 plus 7. 2 to the 4th is 16 times 3 is 48, so that would be 48 minus 4 plus 7, and that would give me 51. And then if I divide both the numerator and the denominator by 3, I get 71 over 17. So substitution worked for that one. For this one, though, if I put the 3 right in, I'm going to get 9 minus 3 minus 6, 3 minus 3. So I get 0 over 0. And in this case, the way I'm going to simplify my fraction is by factoring. So I'm going to factor. On the top, I'm looking for numbers that multiply to -6 and add to -1, and those numbers are -3 and +2. So because these cancel out, I can just plug my 3 into my simplified expression, x plus 2. So I have 3 plus 2, which is 5. Okay, over here we have the difference of cubes. Now in Algebra 2 you learned how to factor the difference of cubes, but let me just see if I can add in a quick page to remind you of this. So the difference of cubes, the patterns are a cubed minus b cubed is a minus b times a squared plus ab plus b squared. Or a cubed plus b cubed is a plus b, a squared minus ab plus b squared. Your Algebra 2 teacher might have taught you SOAP or SOPs to remember that this part looks the same as this. Always starts with an a squared next. This sign is the opposite of the original, so if it started with a plus, this is a minus. And then this sign is always positive. So if it helps you to think of it as SOPs or SOAP, then go ahead and do that. So we're going to use one of these patterns back on this previous page. Okay, so this is the difference of squares. If this is the same as x cubed minus 1 cubed. And so everywhere in the difference pattern where I had an a, I'll put x, and everywhere where you had a b, you're going to put 1. So I'm basically going to copy this pattern, substituting x for a and substituting 1 for b. So let's see, this is going to be x minus 1. Instead of a squared, I have x squared plus a times b will be x times 1, that's just x. And then 1 squared is 1. My denominator stays x minus 1. And so now you can see that these will cancel, and I can substitute 1 into what remains. I have 1 squared plus 1, which equals 3. Okay, let's look at 4. If I substitute the 4 right in, I get 4 minus 4, which is 0. And square root of 4 is 2, so 2 minus 2 is also 0. So I can see again it's indeterminate form, but I've never learned how to factor something like this, so we need to try something different. So what we're going to do is we're going to multiply by the conjugate. And you have done this in previous units. You've multiplied by the conjugate to eliminate i's, and you've multiplied by the conjugate with trig expressions. So let me just remind you one more time that the conjugate of a minus b is a plus b. So the conjugate of root x minus 2 is root x plus 2. And I'm allowed to multiply that in the denominator if I also multiply it in the numerator, because essentially I'm just multiplying the whole fraction by 1. I haven't changed anything. So in my numerator, I'm going to have x minus 4 and root x plus 2. In my denominator, root x times the square root of x gives you the square root of x squared, which is just x. And then I have 2 root x and negative 2 root x. Those middle terms cancel out. And then negative 2 times 2 is minus 4. So notice that's the same as this factor on the top, and those cancel out, which leaves you with just root x plus 2. Now I can substitute my 4 in. I have square root of 4 plus 2, which is 2 plus 2, which is 4. All right, number 5 is another multiply by the conjugate problem. You should probably pause the video here and try to multiply by the conjugate, but if you need a quick hint, for the conjugate of the numerator, you're going to keep the square root of x plus 1, change the minus here to a plus, and then 1. All right, so if you haven't paused it yet, go ahead and pause the video before checking to see if you did it correctly. All right, in the numerator, I have the square root of x plus 1 times the square root of x plus 1, which gives you the square root of x plus 1 squared. So basically, this one times this one just gives you x plus 1. And then square root of x plus 1 times 1 is square root of x plus 1. And I also have square root of x plus 1 times negative 1, which gives me the negative value. So those two cancel out. That always happens when you multiply by the conjugate. So my last term is negative 1 times positive 1. And that gives me negative 1. In my denominator, I still have this x, and I have this, root x plus 1 plus 1. So the plus 1 and minus 1 up top, those are going to cancel, and I get just x in the numerator. Denominator is x times root x plus 1 plus 1, and these two are going to cancel, leaving me with just 1 over this. So now I'm going to substitute the 0 in. I have 1 over the square root of 0 plus 1 plus 1. The square root of 1 is 1, plus another one is 2, so my final answer is 1/2. All right, number 6 is an interesting one. If you want to challenge yourself, pause the video and take a look back at problems, or at the first examples here and here, and think about how can you change what we have to include one of these expressions. Okay, so remember back in trigonometry, we know that tangent x is the same as sine x over cosine x. So sine x over cosine x. That's the tangent x, and it's divided by x here. Now if I'm dividing by x, I can change that to times the reciprocal of x. So the reciprocal of x is 1 over x. So I get sine x over x cos x. All right, now let's look back. The very first example. The limit as x approaches 0 of sine x over x is 1, so I can take that part and substitute in 1. So this is all 1. So it becomes 1 over the cosine x. And I'm doing the limit as x approaches 0, so I would substitute the 0 there, 1 over cosine 0. Cosine of 0 is 1, so 1 over 1 is 1. Okay, let's turn the page. All right, here we have two piecewise functions. For piecewise functions, basically, you're trying to figure out if the side on the left, this is our left side because it's less than 3, and the side of the right are converging on the same number. So like if you thought of this as a piecewise, are the two pieces coming to the same number? So the way you find that out, as x approaches 3, you substitute 3 into the right side and the left side. So I'm going to do the limit as x approaches 3 from the left. That's over here. And I'm going to do 6, replace the x with 3, minus 4. So 18 minus 4 is 14. And I'm going to do the limit as x approaches 3 from the right. So that would be here, and I have 3 squared, which is 9. So because those two are not the same number, this overall limit does not exist. The limit of f of x as x approaches 3 does not exist. All right, you may want to pause the video before you do 9 and check and see if you can find if the limit exists or not. So for number 9, again, we're trying to find the limit at this value where the x changes. This is my left side because it's less than 4, and this is my right side because it's greater than 4. So put the 4 in. Let's do the limit as x approaches 4 from the left. And that's going to be when I substitute 4 in here. So I have 8 minus 2 times 4. 8 minus 8 is 0. The limit as x approaches 4 from the right, and I need to substitute 4 in this one. Square root 4 minus 4. Square root of 0 is also 0. So because those are the same numbers, I can say the limit as x approaches 4 of f of x equals 0. Okay, we skipped over number 8. Number 8, I'm trying to find the limit as x approaches 2 of f plus g of x. So what we're going to do is find the separate limits and then add them together. The limit as x approaches 2 of f of x, see it says f of x here, is going to be the value I'm approaching from the left and the right, which is 1. Okay, so this is going to be 1 plus, and here for g of x, it looks like we're approaching 3. So 1 plus 3 equals 4. Okay, now we're reaching some problems that came from an AP calculus test. And so these limits are going to be very useful once you get to calculus. Here's f of x, and if I were to plug 0 right in, I'm going to get f of 0 minus f of 0, which is 0. And in the denominator, I'm going to have 0 squared, which is also 0. So again, it's indeterminate form, 0 over 0. So what if I substitute, for f of x, I substitute in 2x squared plus 1. So 2x squared plus 1 minus f of 0. When I plug 0 into the function, I'm going to get 0 plus 1. So that's going to be minus 1. And over x squared. So plus 1 minus 1 gives me 2x squared over x squared, and the x squareds cancel, so I just get 2. This is the function y equals 2, which is, of course, straight across at 2. 1, 2. Straight across. It's a constant function. So no matter what value I'm approaching, the y value should always be 2. So that would be this one here. Okay, the next one, the limit as x approaches 1, and that would be 1 over ln 1. So ln 1 means e to what exponent would give you 1? And it's 0. E to the 0 gives you 1. So this is 1 over 0. Now notice my numerator is not 0. It's not 0 over 0. So this is not the indeterminate form. 1 over 0 is undefined, and so this limit does not exist. Does not exist, which is e. All right, number 12 is another piecewise function, and we're trying to find the limit as x approaches 2. So this is going to be less than 2. This is the left side, and this is greater than 2. This is the right side. All right, so I'm going to substitute 2 in, and I get ln 2 on the left, and on the right, 2 squared is 4, so I get 4 ln 2 on the right. Now, even if you're confused about what ln 2 is, you can see that this answer is 4 times as large as this answer, so they're not the same number, and because the left side and the right side are not the same, we would say that the limit as x approaches 2 for f of x does not exist. So it's this one, non-existent. Okay, now 13 is a problem that we can solve by factoring. So you can pause the video and take a minute to try to factor it. If I look at the numerator, I see the difference of squares here, and I'm going to put the difference of squares pattern on the next page for you in just a minute. But notice that the denominator also has the difference of squares because x to the fourth is x squared squared, and a to the fourth is a squared squared. So actually, I think I can fit this on this page. I'm going to give you your difference of squares pattern. So the pattern is a squared minus b squared equals a minus b times a plus b. Okay, so this numerator could be factored, but I have a feeling if I start by factoring the denominator, it might be a little bit easier. So what if I keep this x squared minus a squared? And then my denominator, because this x to the fourth is x squared squared, I can have x squared minus a squared times x squared plus a squared. And then when I factor, or when I cancel these two out, I have 1 over x squared plus a squared. So I'm doing the limit as x approaches a, which means I'm going to put a in for x. So this becomes 1 over a squared plus a squared. And then this is going to be 1 over 2a squared. So 1 over 2a squared is right here. Okay, so I think that's the end of this video, and you should try the homework problems.